All right, so today we're going to continue and we're going to go on to the next topic, which are strings. Strings are super easy in Java, and now that you have arrays under your belt in C, they're going to be still a little bit getting used to, but it's basically just an array, right? It's an array of characters instead of an array of integers. Remember that we are on Piazza, we are on YouTube, so if you have any questions, go ahead and post there. Otherwise, what are strings? Well, strings are just a sequence of characters. Now in C, that's going to be ASCII, right? The basic ASCII character set. Lowercase a through z, uppercase a through z, 0 through 9, etc. All the punctuation characters. It's limited to 256 characters. In Java, that's going to be full Unicode support. And you can bring in a library in general in C for Unicode support if you really want to, but we won't have cause to do that. And Unicode means it's a much larger character set. CJK fonts, for example, Chinese, Japanese, Korean symbols, even ancient Egyptian hieroglyphics, and of course, more modern emojis are all part of the Unicode standard, right? Different languages represent things differently, and this is one of the key differences between C and Java. Most languages, however, provide some sort of a standard library to make your life easier to manipulate and process strings, and both languages, C and Java, do provide that. All right. So what about C? Well, that's where we'll start because that's the more difficult one if you want to think of it that way. I'll make sure that it pops up here. There we go. So in C, strings are simply arrays of characters, i.e. a char array. Right? So it's not like an integer array or a double array, but it's similar, right? In that if you have an integer array, what do you have? Do you just have int? Like, is this an integer array? Int a. There we go. No, you need either a bracket to make it into a static array, but generally you want to avoid those, or alternatively a pointer. Right? Well, if that's an integer array, then what's a character array? What does a string look like? Char star, and I'll call it S here instead. Right? So in C, you can have static strings, say char S like this, or better, dynamic strings, right? With char star S, okay? But there is a huge caveat here in C. And in fact, I'm going to put that into bold there. In fact, I can put it in bold and italics here. For a string to be valid in C, it must be ended or terminated with a null terminating character. Now the null terminating character is this special character. It is /0. And I'm putting the single quotes around that because remember, in both languages, if you want to define a single character, you use single quotes. That backslash there, 0, is an escape character. Just like, how do you get the end line character? You can't just hit enter. What do you use? Backslash n. How do you get the tab character? You can't just hit the tab, right? That actually tabs over. So you do backslash t for tab. This is a /0. Now, if you look at your ASCII text table, right, capital A has a value of 65 or 95 or something like that, right? But if you look all the way at the beginning, there is indeed a place where the value is 0. That's the null terminating character. That's where you'll find it. It comes before all of the other characters. It's this very special character in the ASCII text table that indicates that here's my string, so character, null terminating character, that's the end of the string, right? And it's necessary in C because that's how C treats strings. You don't need an end line, you don't need a null terminating character with an integer array or a double array, do you? No, you just need to do your own bookkeeping. If you create an array of 100 integers, you need to remember that that was an array of 100 integers. With a string, it's a little bit different. Here's a string. How big is the string? Well, it depends on where the null terminating character is. And that's the end of the string, okay? Do not confuse this with other things that look like null, all right? It is not the same thing as 0, right? It has a value of 0 in the ASCII text table, but you should not treat it like 0, all right? It is not the same thing as the 0 character, right? The 0 character being 0, right? Without a slash. That is a valid character in the ASCII text table and it would print out 0, right? It is not the same thing. It is not void, right? It is not null, right? Null is for pointers. Void is for functions and sometimes pointers, right? So we've got a lot of things here that mean nothing, a lot of things that mean 0. Now we've got a new thing that means 0, but in a different context. Another confusing thing that people often use are, since we call it, it must end with a null terminating character, some people confuse it with the endline character. It is not the space. It is not the endline character. The endline character, of course, being /n, like we said before. Okay. If an array of characters, and in other words, a string, or actually, no, I'm not even going to call it a string. Characters is not null terminated. It is not a valid string, and any operation on it is undefined behavior. If you have a non-null, an invalid string, and you try to print it, if you have an invalid string and you try to concatenate it with another string, or you just try to figure out how long is the string, right? All of those operations, which are provided by the string library, will be undefined behavior, okay? You're going to have a bad time to do it if you do that. Here's a really quick example of a static string, right? Hello world, right? Now, as you said, I put the square brackets here, right? And I didn't define the size. I could have HELLO space WORLD exclamation point. So would this be valid? What if I put 12 over there? Nope. I counted the hello world itself takes 12 characters. What do I need to accommodate at the end in C? I need to accommodate the null terminating character. So if I wanted to specify the size, it would need to be at least 13. You can go further if you want to. Make it 100. Now, what does that string look like? It's got hello world in it, followed by the null terminating character, and then a bunch of wasted space. Maybe not wasted space in that if you need to use that space or something like that, that's perfectly fine. You make the string, you concatenate to the string, and you make it bigger and bigger and bigger until you hit that limit. Whatever, all right? So it may or may not be wasted space, but it's certainly going to be an array that holds 100 characters. If I did that and I changed the contents of that array, what is the maximum size or maximum length of a string that I could put into that array right there? Is it 100? 99. Why? I need at least one space for that null terminating character. Okay? Using this syntax, the compilers are dumb, but at least they can count, just like I just counted, right? That there are 12 characters in there, plus 1 for the null terminating character, and it takes care of it for you, right? So again, in this example, the compiler will take care of the null terminating character for you. The actual size is going to be 13, 1 additional to account for the null terminator, right? If you don't put that in there, then again, it's the compiler taking care of that, right? Here's another example, right? I can make my name an array of size 100. It could hold up to 99 characters, a string of up to length 99. But here I'm just going to put my name into it, right? You can create arrays with those larger space if you need to, say, temporary working space or something like that, right? In C, all strings are mutable. So this is one of the major differences between C and Java. Strings in Java are immutable. Once you create them, you cannot change them. And we'll get to that later. But in C, it's just a regular old array. So you can mutate it, you can change it as much as you want. So for example, let's go ahead and correct my name here. Right? Remember that my name is lowercase. Right? So I need to change the first character here to capital C. How do I go about doing that? Name sub 0 is equal to, is this correct? If you're going to set a single character, do you use double quotes? Nope. You use single quotes. Right? And now the name has been changed. How do I print the string? Printf, hello, and then my name and the line, and I'll print out my name. What placeholder do you think you use for a string? Percent. The C is for single characters, so this is the other one that makes sense. C for characters, S for strings. Right? There we go. All right, let me go ahead and take it over to the CS50 IDE here, and we'll just go ahead and get rid of this stuff. Ignore previous demo. And you can see it in action here when I run it. Hello, Chris. That end line character there is I'm printing that. That's not part of the string. Right? My string is just Chris here. Well, let's go. I left enough space there for my full name, Christopher, right? So let's go ahead and correct that too. Names of, let's see, C-H-R-I-S. So that's 0, 1, 2, 3, 4, 5 should be T. Right. Names of 6 should be, this seems like it's really tedious, right? To, et cetera, et cetera, et cetera, right? Should I look for a better way here? Do you have to set every single character, right? For example, let me try this. Name is equal to, this is something you'd see in Java, my full name instead. Let's see if this even compiles. And it doesn't. You cannot use the assignment operator once a string has been created. You can use the assignment operator when you declare and create a string, but you can't use it after that. Right? So am I forced to do things like this? No, thankfully there's a solution. But let's think about this for a second. Obviously this will not work. Right? You cannot use the assignment operator after a string has been created. Right? So I'll comment that out, but I'll include it in the notes here in a second. Let's think about name for a second here. So it started out as CHRIS, and then the compiler automatically put in that null terminating character for me, and then I overwrote it with a T, and then O, right? Dot, dot, dot. Okay, is that a validly null terminated string? Remember, I overwrote it. Right? Let's find out. Let's go ahead and print out character by character in that entire thing. So for int I equals 0, I is less than 100, I plus plus, printf, I'll print out each character. So names of %d is equal to %c and the line, I and names of I. Right? You see I'm printing out the index, and I'm also going to be printing out the individual character one to a line. This will actually compile, so we're good. All right, there we go. So CHRISTO. Darn it, I didn't get it to fail. Okay, fine. I'll try it even further. Name, char full name is equal to whatever, and I'll make it of size 100. And I'll try another one here, char middle name equal to Michael. There we go. Let's try this one more time. Oh no, last time it was putting out garbage. Anyway, if I just have a regular old array, say full name here, if I don't assign it a value, What are the contents of that array right now in C? Garbage. It could be zeros. In other words, if it's all zeros, then it's all null terminating characters, right? But it could be garbage. It could be what was ever left over in there. It could be all zeros. You don't know, right? It's a crapshoot. And unfortunately, I was not able to demonstrate that with this particular example, but that's the compiler saving me from myself, right? So back to this question here. Is this a validly null terminated string? It looks like it, but cross your fingers, and the only reason it looks like it is because we got lucky, okay? So after setting everything, you need to make sure that it is a validly null terminated string. How? Oops. By explicitly setting the null terminator for you. Right? And by the way, that will work for any string. Let me go ahead and back up here and put in my full name. There we go. And I'll print it out. Hello, %s, and the line, name. And then I'm going to change that string. What I'm going to do is I'm going to change my name to just my shortened name. So CHRIS 0, 1, 2, 3, 4, and then at the fifth, index 5, I'm going to set the null terminated character manually. Now, when I print this out, you will see hello Christopher, and then hello Chris. Right? And then looks like I'm printing it down here too. Right? Let me go ahead and get rid of that. Right? Hello Christopher, hello Chris. What about this OPHER? Is it gone? Is it lost? Nope. In fact, let me show you in Python Tutor. Right. So let's visualize this execution here. It's going to create an array of size 100, and it's going to put Christopher into it and the null terminating character. Right? And this is after line 3, right? And just by convenience or by convention or whatever, it filled it up with null terminating characters. Okay? When I set the 6th character, right, because index 5, that's actually the 6th character, to the null terminating character, you see what happens here. That's been null terminated. What about OPHER and the rest of it? Unchanged. If I were to switch that back to T, then I would restore my full name. A string always ends at the null terminating character, period, in C. Right? Okay? So how do we go about assigning values? Right? Again, after a declaration, after the initial declaration, you cannot use the assignment operator. Right? You can manipulate individual characters, but you cannot reassign the entire contents using the assignment operator. Right? Instead, you could copy over character by character by character if you want to, but again, that gets tedious. Instead, you can use the string libraries, strcpy. What do you think strcpy is short for? String copy, right? Yay, we saved 4 characters. 40 years ago, if you could do that, you did. Right? Yeah?
So you have a string called Christopher. If you switch out like the T to a no terminating character, when you print the whole string, you can only get like.
You only it always ends at the null terminating character.
But if you do like printf name and then the index 6.
Oh yeah, you could do it manually.
Okay. So
For int I equals 0, I is less than. We'll just go up to 15 here, I++, right? Printf. Now, printing individual characters is, of course, going to be %c, and then names of I. What do you think happens when you print a null terminating character, by the way? It's an unprintable character. In fact, the lower order characters in the ASCII text set are all unprintable. Some of them would result in like old school beep. I think that there's one actually called beep. I forget. ASCII table. While we're waiting for here we go. So here is Christopher, and then for my for loop here, it's going to end up printing CHRIS, and then null terminating character. It just didn't print anything, but it actually executed there. And then Come on, keep going. Oh. Okay. It died. I don't know why. Whatever. All right, but it would work. I'm pretty sure that it would work in a regular old program. Let's just go back over here and make sure. All right. It was working before, at least. Yeah, there we go. Chris, oh, because there's nothing to print, right? So there's Chris, and then T, right here, you see it? It's the null terminating character. It's not printable, right? So, but it does print the next line, and then OPHER, and then we went on, and the rest of them were null terminating characters too. Yeah?
Would you want to print one character, or do you just print it as a string?
Well, %C, what do you mean?
Like %S, but then
This will...
you make it one string with one. You make it a string with only one character.
Okay, so there's a distinction there. So good question here. Char S is equal to, I don't know, A. Right? That is not a character. That is a string. It's a string of size what? 1 plus the null terminating character. Right? So it actually allocates 2 bytes instead of just 1. Char C equals A. There's no null terminating character here at all because it's just 1 character. The first one is a string. The second one is a character. Right? So there is a difference there, and you have to treat them as such. Right? Yeah, go ahead. I just did this really quick here, but there is a subtle difference between all the static declaration. You can change it. A dynamic declaration right here, then you use malloc, which we will here shortly. You can change it. This ends up making a read-only string. So let me go with hello. Let me demonstrate what I mean by that. Let me go ahead and try to change that. S of 0, I'll change that to uppercase H. Right. And this, I think that this will be a compiler error. Oh, no. Oh, okay. It's letting me do this? Amazing. Okay. Print, let's make sure it actually works. %S, %S, and the line, and S. Okay. There we go. Cool. Segmentation fault. I don't understand why the compiler was not able to, let me recompile with the full wall flag here. The compiler should be detecting this, but it's not. That I've created on line 9 a read-only string. It is a pointer to this memory location that holds hello all lowercase. And my attempt to change it on line 10 results in a segmentation fault because it's read-only memory. You tried to write to it and change the lowercase h to an uppercase h, so segmentation fault, illegal operation. The compiler should have been smart enough to figure that out, though. It's basically kind of like doing this, const, where you can't make, I'm making the promise I'm not going to make changes to this. And hopefully the compiler will definitely see this, right? Yeah, there we go. So the other way the compiler was not able to see it, but now it is. Right. Let's take a look at where is it? There's, of course, a line feed, device control 1, 2, 3, negative acknowledgement. There should be like a beep in here or something. Carriage return, where are you? Anyway, there, bell. 7. If you tried to print out ASCII character 7, let's find out. I don't know. Let's try it. Char C is equal to, and I can't type it out. Obviously, I'm not going to type out BEP. What did it call it? Bell, right? I'm not going to type out bell. It's a special character. But what I can do is I can treat an integer as a character and manually get that value, and then try to print this out. And my okay, I don't have any sound here, but let's go ahead and try it. Okay, my sound is off, so I don't know if it actually beeped or not, or belled or not. But you can try it at home and do it. You can actually make music using those invalid ASCII text characters and stuff like that. All right. Just a little bit of amusement there. Anyway, back to string copying. Right. Again, you can't use that assignment operator once you've done it. Once you've created a string. Instead, you use strcpy. Where do you think it's located, by the way, in the string library? The string library is in, the math library is in math.h. The input-output library is in std.io or stdio.h. So the string library is in string.h. Right? And all you have to do is bring that in. Here is the signature of the string copy function. Let's make some observations about it first of all. The first argument is the destination. Right? The string you are copying to. Right? The second argument is the source, what you are copying from. What are they? Char star. What is a char star? A string. Char star source, that's also a string, but it's got this additional keyword in front of it. What does that mean again? It's not changing it, right? The second argument is read only. Yay. The first argument is definitely read and write, because of course if you are copying one string into another string, then you do need to make changes to that first string, right? The order mirrors, or not mirrors, but is similar to the assignment operator. You take the right one and put it into the left one, right? Just like an assignment operator. A is equal to 10. You take the thing on the right-hand side and you put it into the variable on the left-hand side. That's why it's ordered like that. It is on you. It is, this function assumes, I'll emphasize that, assumes that destination is big enough to hold the source string. This function assumes that the source string is a valid null terminated string. If neither one of those assumptions is correct, then you're going to lead into undefined behavior, right? But it will take care of the null terminating character for you. strcpy will, I'll emphasize that, will copy the null terminator for you. Right? So again, if I want to copy in my first name here, we'll just go ahead and go into code mode here, char star, or char full name, right? I can go ahead and I'll make it of size 100 here. I can use strcpy. Instead of saying CHRISTOPHER, I can say string copy into full name, a hard-coded value, Christopher. Right? Now that hard-coded value will be null terminated automatically, and it will copy the contents directly into my full name, into the string called full name. Okay? How big is that string again? The array is of size 100, but what's the length of that string right there? I think we said it was what, 12? Right? How can I determine that? There is another function. Another useful function is strlen. What do you think that stands for? A string and then len is length, right? It returns an integer indicating the number of characters not including the null terminator. Right? So for this particular example, it would end up returning what? Let's find out. Is it 11? I thought there were 12. Well, let's find out. We don't have to strain our brains, right? Int, I'll call it n, right? str, what? len of full name, and printf, my name has %d characters, end the line, right? N. Now remember, I do need to bring in that string library. So if you're going to be working with strings and using things in the string library, that's yet another standard thing that you put up at the top. Okay. Let's run it. I think it's 12, isn't it? Oh, it's 11. Okay, you were right. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yay. Yeah.
So the length only counts the actual characters in the string. It doesn't count the.
Exactly. It does not include that, not including the null terminating character. Right. So you always have to adjust, right? If I want to say make a deep copy string of my name, and I allocate space to do that, I don't allocate 11 in this case. I allocate 11 plus 1 to accommodate that null terminating character. In fact, let's do that as an exercise. So I've got my full name here, right? Let's go ahead and create, let's go ahead and perform or create a deep copy of my full name. Do we remember the difference between a shallow copy and a deep copy? Shallow copy would be two references referencing the same thing, so that changes to one are affected by the other. But a deep copy means that this reference is referencing that, this reference is referencing that, so two completely different strings here. Right? And what we're going to do is I'm going to prove to you that, we're going to do it, and then we're going to look at the effects yet again. Okay? All right. I'm going to steal that. All right. And what I'll do is I'll print them at the end here. Right? Let's make a deep copy of my full name. First of all, I need to know how many characters there are. Right? Then I need to allocate enough space to hold the copy, ... So here's my copy. I'll just say it's C for copy. And I call, what do I need to do to create a brand new string of a particular size dynamically? Malloc, right? Malloc. Just like you use malloc to create an integer array, like you use malloc to create a double array, you use malloc to create a character array, a char array, in which case you've got a string. Right? Yes, that's why I left that there. So what is the typecast? Otherwise, I would have given away the answer, right? Malloc. Size of, well, what are you allocating again? Are you allocating integers? Nope. Are you allocating doubles? Nope. You are allocating chars. How many of them do you want? Just n? 11 to hold Christopher plus 1. Right? Now, I see this all the time. Think about this. Is this good math? Right? You're going to get away with this simply because a character is always 1 byte. Right? So plus 1, fine. But really, the better way of doing this is to put it like that. Right? You're going to get away with it, but not because the math is correct. You're going to get away with it because it just happens to be the case that a character is 1 byte. Right? Now, does that solve? Does that solve the problem? Let's find out. Printf %s or full name equals %s and the line full name and printf. Oops. Full name is equal to, or what's the copy? Oh, C here. So that they nicely align. I'll just go ahead and do that. Right. C is kind of a bad name though, right? What does C tell you? Looks like a character to me. Let's call it copy. There we go. What's it going to print? Nothing. Why? I didn't actually copy it, right? I just created enough memory to hold it. So let's actually copy using strcpy. It only copies the contents. So strcpy into copy, oops, the full name. And now when I do this, it will have that full copy there. Right? And it will be a deep copy because you can change the values. Copy sub I, or 0, sorry, is going to be a capital C now. And you'll see that the full name, the original, is unchanged, but my copy now has a capital I, a capital C. Question?
So can we also do shallow copy?
You can, but then changes to one will affect the other. Right? Yeah, you could have done something like this, maybe with a warning full name. There we go. I'm interested. Are you going to warn me about doing that? Yep. Well, okay, no, you're not. You're going to warn me about something else. Now you see that they're both changed because it was a shallow copy. Don't want to do that. I want a deep copy. Yeah.
Is it okay that we made a deep copy of the static array?
It's okay, yeah. You can make a deep copy of anything that you want because you're not even touching it, right? Yeah, I could have made this into a const char array, and I'm not making changes to it. I'm making a copy, and then I can make changes to that copy instead, right? What else? Oh yeah. What if I just did this? Is that going to be big enough? Nope. Let's find out what happens. Hopefully I'll break it here. Nope. This didn't break, but that's only because I got lucky. And it's such small strings. If you start manipulating strings and eventually get into a page or a segment of memory that doesn't belong to you because there's no null terminating character, that's when you get your segmentation fault, right? But I'm getting away with it here. It's hard to force errors. But anyway, let's go ahead and, this seems so, common. Create a deep copy of that string so that you can change it, so that you can manipulate it, so you can process it. But don't touch the original because we still need that data. That seems like such a common operation. Maybe we can put it into a function. Right? All right, I already documented this. So let's put it in, surround it with a function. What should I call this function, first of all? Should I call it CPY, strcpy? Can I call it strcpy? Not without bringing in the string library here, right? Not because I brought in the string library. If I didn't bring in the string library, of course I could use that name, but it's already been used. Right? All right. What should I call it instead? String copy. Don't get cheap on the characters. Okay, I like that even better. A deep string copy. Okay. What's its return type going to be? An array of characters. And how do we do that? With a star, char star. Right. What should it take as input? An array of characters, the original string there, right? Now, do I need to also pass in the size of that array just like I did with integers and doubles? No. Why? Because I've got this guy right here. Right? It'll go through, as long as it's a validly null terminated string, it'll go through count, okay, there are 11 characters in Christopher. Right? There you go. And you don't need to pass this in as a parameter. Right? I've got n of s, the original, and original right there. And then, am I done, by the way? Yeah, let's turn on all the warnings. Warning, controller reaches end of non-void function. You have a return value here. Am I actually returning anything? Nope, so what should I return? The copy. Is it right to return S? What happens if I did that? Let's think this through. You gave me a string. I created a deep copy. It's over there. There's copy. And here's string I'm pointing to. These are both pointers. And then I give you back the pointer. What happened to that memory over there? You witnessed it yesterday when you ran valgrind. It leaked, right? It's gone. You can't clean it up, right? And you do that over and over and over again, valgrind eventually grinds to a halt. Right? I don't know if that's why it's called valgrind or not. I don't know why. Right? Anyway, copy. Right? Any questions so far? Yeah.
Is it just kind of something general? What do you mean when you have return semicolon?
Return semicolon, that's for a void function. You don't explicitly, you don't need to explicitly use return semicolon because it's a void function, but it's still best practice to do so if you do it. Yeah.
Do we still need to free up that memory?
Good question. Okay, so would this be appropriate? Well, so you gave me a string, I copied it, and then I'm going to destroy your string, right? Probably not. The memory doesn't belong to me. It belongs to you, right? That goes back to ownership. Who owns this memory? Therefore, who's responsible for cleaning it up? Now, what about the copy? Right? You gave me a string, I copied it, and then I destroyed my work that I just did without giving it back to you. Right? That doesn't sound right either. Right? Now, granted, eventually, for now, I do own this copy, but once I give it back to you, now you own that memory and you're responsible for it. But also, it's like you call the square root function, and then it said, okay, square root of 2 is 1.41, but I ain't going to tell you. Right? I'm going to tell you nothing. Right? That's the whole point of making a function, so it actually gives you something. Right? Yeah.
So would whoever is calling this function want to end up freeing either S or copy?
Eventually, they should. They should definitely. So let's go ahead and look through the full example here. Christopher, instead of rolling this, what I'll do is char copy is equal to, what did we call it? Deep string copy of full name. There we go. And then, strictly speaking, let's style this. There we go. No, I didn't want to have to deal with all the tabs and the stuff there. Strictly speaking, I should free full name, and I should free, actually, can I? Do you free static stuff? No. So let's find out what happens though. Free copy. I believe that it's going to say stack smasher. At least that would be the cool thing that it would do. Okay, it's just a warning, right? Thank you for your warning. And if I actually tried to run it, oh, okay, darn it. A double free or corruption. So it should have been a stack smasher because this is allocated on the stack. Therefore, you tried to free something on the stack. You can't do that. You can free the heap. You can't free the stack because you're destroying your own program's memory, basically. And you don't want to do that. So definitely not the full name because that's static. But copy, certainly. No warning now, and it runs perfectly fine. And if I ran this through Valgrind, it would say that there's not going to be any memory lost here, right? No errors or anything like that. But if I don't free the copy, technically, it will say that you lose those bytes, right? One error. How many bytes did we lose? 12 bytes. That's going to be Christopher 11 plus 1 for the null terminating character. That's how much we lost. But it's at the end of the program. Who cares? Right?
Did we not lose anything for S?
Nope. Because for S.
Yeah, I think that was.
No, we didn't create S. We were given S.
Oh,
Right? Yeah, again, if you free S here, we're rolling the dice to find out what happens here. Let's just run it pure, yeah, invalid pointer, right? Why? Because this ended up freeing it, which it shouldn't have done. Then we tried to print it, which we can't. In fact, it doesn't even know that you're trying to free up the stack space. This should have been a stack smasher. I don't know why it wasn't. Right? And then Valgrind. I wonder what Valgrind says about doing something like this, other than don't do it. Here we go. Invalid free, delete, or delete reallocate. In deep string copy on some line, it doesn't know what line it is because I didn't use the G flag. Yep. Address is on thread 1 stack. You tried to delete the stack, and it won't. You can't do that. That's the message Valgrind is giving you. Yeah.
So the Y and then the hexa thing, in the Valgrind.
Yep. That's the line number of the machine code, and since it's a memory address, that's all it can do. Here, let's go ahead and restore that. And if I compile though with the G flag, it'll retain all of the variable names, it'll retain all the function names, and all the line numbers, so that when you run it through Valgrind, you'll actually get a line number out of this now instead. Right? They're the line numbers. It's still going to give you the memory addresses here, but at least it's telling you that on line 19, you called deep string copy, and on line 8, that's where this error occurred. Right?
And then the memory address changes every time. So
Probably, yeah. Unless it's running it through a simulation where the memory addresses become more predictable or something. This was 109.23a. 109.23a, so it's probably repeating how it allocates memory. All right. Or was it something else? Where? Oh, that might be something else. I don't know. All right. Don't get bogged down in the memory addresses and the hexadecimal garbage, right? But anyway, there. Okay. So that's our deep string copy. Another operation would be concatenation. So when I say concatenation, what does that mean to you? Is that a regular word? You get so steeped in tech talk that you forget what words are actually used in the real world and what are not. And I always thought that concatenating two things together was a real world term, right? No? Taking a string and appending something else to the end is probably the most common term. But with respect to strings, it's called concatenation. And you can use strcat. Cat is short for concatenation. Don't ask me why it's not con. There is an strcon. It does something completely different. Right? That's probably what they wrote that one first and then realized, oh, well, we already used that name. All right. Cat. We'll go with the next syllable there, right? Again, there are only two difficult things in computer science: cache invalidation and naming things, right? And you see the consequences of it. So here's strcat, and it's almost exactly the same as strcpy. It has a destination, it has a source, but instead of copying the source into the destination, it will simply just append it at the end. Right? If it's HELLO, you can go ahead and append to the end of that the destination. It won't mess with the original string. It'll just add it to the end. Of course, it assumes that it's large enough to hold that and that the original source is null terminated. And if so, it'll take care of the null terminator for you. Again, let's go ahead and take a look at a full example here. I'll keep my full name here. I'll go ahead and copy over str or Christopher. And then if I tried to put in my last name, strcpy, using strcpy, what's it going to end up doing? It's going to end up overwriting Christopher, printf. In fact, let's take a look at this visualization here. So I'll end up with BOURKE, then the null terminating character, then there we go, Burke, and then the null terminating character, PHER, and then the null terminating character. Right? And that's even cooler because right now it's showing you that this is statically declared, so it didn't automatically fill it with a bunch of null terminating characters here. Right? But I can't use strcpy without clobbering, and that is a term used in tech. If you overwrite something accidentally or as an error, you're clobbering it, right? Clobber. Right? You're clobbering. I guess they've never. Everybody's familiar with the Marvel comics, but nobody's familiar with the Fantastic Four because they've never made a good movie yet. All right. So what does the Thing say? What's his catchphrase? It's clobbering time. What does clobbering do? He's smashing things. It's Hulk smash, right? So you're clobbering things, you're destroying things. And you don't want to do that, right? Instead, you want to concatenate to it. And let's go ahead and see what this does. Printf name is equal to %s and the line and full name. Is this going to get me what I want, though? Let's find out. Uh-oh. No space. Okay. what could I do? Well, I could put in a space right here, or I could concatenate a single space. And this kind of goes back to your question of, can you have a string of size 1? Yes. Of length 1? Yes. But it is a string, it is not a single character. Yeah? Yeah, that would have worked too. In fact, you could put 2 spaces there, and you'll see that there are now 2 spaces. It's double spaced instead. Okay. All right. There are byte-limited versions of both of these things. And I'll just go ahead and cut and paste this and talk about it. All right, there we go. So there is strncpy, and there's strncat. Right? The n there stands for a limited number of bytes that you want to copy at most n bytes. Either copy or concatenate at most n byte. If either function sees a null terminating character before it copies n bytes, then it stops. So it's an either or kind of thing. If you say that n is 5, it'll copy over 1, 2, 3, 4, 5 bytes and then stop. But if it sees a null terminating character before that, CHR and then a null terminating character, it stops prematurely. Right? Again, it is at most. It's the maximum number of characters to copy or concatenate. Right? So there's no guarantee that it's going to do all of them. It's just going to go until it sees that first null terminating character. Otherwise, the null terminating character will not be copied for you. So this is a difference with the strcpy and strcat. Here, it becomes your responsibility to take care of that, right? If it's not already taken care of. It's very useful to use this with substrings. Right? So what is a substring? If I have a string, then part of a string is a substring, right? So the example, I'll go ahead and let me go ahead and give myself an example to work with here. There we go. My full name, I'm going to go ahead and copy in Christopher M. Burke. Right? And what I want is my short name, short name, Chris, C-H-R-I-S. Right? Short name, and it's going. How many characters do I need to hold that? 5. Right? Is that going to hold C-H-R-I-S? It will, but you're forgetting the null terminating character. So I need to make it at least 6. Right? And now I'm going to copy only the first 5 bytes of full name. strcpy of into short name, full name, but I only want to copy at most n bytes, and in this case, 5 bytes. Okay? What's it going to do? It's going to go ahead and go copy CHRIS, but what about that last character there? It's not going to copy it because did you see do you see a null terminating character within these first 5 characters? Nope. So you need to take care of that for yourself. So take care of the null terminator. And that will be short name sub 6 is equal to the null terminator. Is that the last index? CHRIS 0, 1, 2, 3, 4, 5 is what it should be. Again, you're always off by 1. Okay? Yeah?
So as long as you don't try to access it before you add no terminating character,
Yeah.
there won't be like a second.
You can be in an indeterminate state, kind of like Schrodinger's cat, right? Where it's not a valid it's not a valid string, but as long as I don't do any invalid operations on it, it's okay. Right? All right. There's the short name. Now what if I want okay, yeah. You can also use strcat and copy copy to get a. Actually, no. Yeah, to get a substring. I'll go with this. Okay. Let's go with team. Right. Char team is equal to Nebraska corn huskers. There we go. Now what I want to do is I want to get just corn huskers. I want to get that substring, okay? And I'll copy it into char, I don't know, again, it's difficult to name things. Short team, there we go. And I'll just make it large enough, it doesn't matter, 100. And I just want this substring right here. Where does this substring begin? So 0, 1, 2, 3, 4, 5, 6, 7, 8. So it begins at 9, right? Team of 9 is teams of 9 is where corn huskers begins. ... I'll put that into a comment there. So how could I just copy that one part over into short team? If I did strcpy into short team, what will that end up doing?
Copying the whole thing.
That'll end up copying the whole thing, okay? I don't want to copy the entire team name. I only want to copy the string starting at index 9. But now be careful. What type is this? Teams of 9? Is that a string?
Sure.
That's one single character. So it's think of it in terms of pointers. Team is a char star. Team is a char star. Team sub 9 is, is a char. How do I turn team sub 9 back into a char star? Ampersand team sub 9 is a char star. Right? It's basically doing the pointer arithmetic and advancing that pointer over 8 bytes, right? Or 9 bytes, whatever it is. Right? So strcpy, and let's go ahead and print it out. Printf short team is equal to %s and the line short team. There we go. Run it, and see that it's been copied over. But what if I only want to copy over, say, corn? Right? I only want to copy at most 4 bytes. I can use a combination of these two things, only over 4 bytes. Now, be careful. Is this going to be a valid null terminating string? I'm probably going to get away with it, but that's because of what was put in here automatically, right? Corn, yeah. Do you see a null terminating character within the first 4 bytes of corn? Nope. So what would I have to do to make this absolutely correct? Short team sub 5 is equal to the null terminating character. Right? And now that's correct. It's the same result, but at least it's correct now. Right? Questions so far? Yeah.
So when you make that team and then you left blank, it just makes it enough so that they fit the string?
Yep. That's that fancy word again, elision. You elide something. You take away the unnecessary parts, and you shorten it up so that the compilers are dumb, but it can count up the number of characters here, add 1 for the null terminating character, and take care of the memory for you. Right? I'll make sure that you've got this in your notes. And then, oh yeah, that's right. This the honors section does not have Xi books, but the main section does. So you might be unaware of these other useful things. Right? The string library has several dozen other functions. How do you know what's there? Read the manual or RTFM, right? Just search for, I need to do this operation. I wonder if there's something there that will support it for me. And yes, there is. 3 times out of 10 there will be, right? There's also the C type library that has a bunch of character functions. For example, if I give it a character C, right, and you can ask it, is it a space? That's going to be true if C is a space character, either this actual space, the end line character, the tab, etc. If it's white space. Is upper will return true if it's an uppercase A or an uppercase B or dot, 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 an uppercase Z. False otherwise. Is lower, and then you can also convert things. If you need to convert a lowercase letter to an uppercase letter, you can call to upper or to lower, right? Etc. You can read the manual there. Again, a couple of dozen functions there that you can use for convenience. Right? What about strings in Java? Again, a lot of you have Java experience already, but you know that it's already kind of built in. Right? I don't want to say that it's actually built into the language because here's another vocab or high concept programming language concept. First-class citizens. In neither language are strings known as first-class citizens. In both languages, integers are first-class citizens because they are built into the language, right? You can always go, say, int a, right? And the language itself, let me go down here. The language itself knows all about integers. It knows how to assign integers. It knows how to add integers. It knows everything that you would possibly need to know already, use for integers already. An integer is a first-class citizen in both languages because you can declare it like this. Right? Now, in C, strings are not first-class citizens. Instead, to get strings, we have to use char star. The first-class citizen here is a character pointer, not a string. Right? Now, in Java, if I had something like string int a, that's a first-class citizen, right? Because it's an actual built-in type. What about a string in Java? Is that really a built-in type? It's not like lowercase I int. It's not like lowercase d double. There are actually only, 7 primitive types, built-in types? Int, double, float, byte, boolean, long, what else? Short. I got them all, yay. Right? Anyway, string is not a built-in type. String is a class. It is part of the standard library. In fact, it's part of java.lang, so it's part of the language library, but it is an actual class. Right? What do you think it looks like under the hood, by the way? String s is equal to hello. Let's find out. It's a class, right? I wonder, how does it represent this thing? Let's find out. Byte coder, come on, really? Compact static. All right, fine. There's the actual value. What is it? I don't know if this is the actual value, but this is basically what it's doing under the hood. It's a byte array, right? That sounds familiar. That's how C does it. It's just that Java builds this class around it so that you don't have to worry about those mundane lower level details. You don't have to worry about null terminating characters. You don't have to worry about allocating things that are something that's just big enough to hold your string. You don't have to worry about any of those details. If you want to reassign this string to be goodbye, haha, you can. Right? Originally it was 5. Now it's 7. Right? Magically, right? It's taking care of all those details for you. It didn't actually expand the array that's under the hood. It actually created a completely brand new string because strings are immutable. You cannot do something like this in Java is equal to lowercase h. Because s is not an array that you can index. There's an array under the hood, but you can't have access to that. Right? They're immutable. But how can you do string copies instead? Well, you just do them. Right? Goodbye. You don't have to call strcpy. You don't have to make sure that it's big enough. You don't have to worry that it's null terminated. Right? It's all built in. If you want to concatenate something, string message is equal to s plus world. S plus a space, then plus a world. And system.out.println message. Right? It takes care of everything for you. The pluses are built in. Goodbye world. Right? The pluses are built in operators. Right? Now, again, this is just syntactic sugar. What's actually going on is the compiler is actually taking this plus and it's replacing it with code that will achieve what the plus is doing. And it'll actually replace your strings with a mutable type of string, probably a string builder or a string buffer or something like that. Right? And we'll talk about those next week. But otherwise, there are the two operations that we just covered. It took an hour to cover in C. You don't need to worry about them in Java. Right? Okay. All right, there are plenty of. Yeah, I'll put it in here. There are plenty of functions that you can call. I've got a web browser here. So Java string. If you just RTM, read the manual, or to emphasize RTFM, right? And there. So I wonder, is there a function that will allow me to have a substring? Yeah, there is, built in, right? Is there a function that allows me to find the length of a string? Yep, right there. Is there a function that allows me to replace characters and return a brand new string? Yep, replace all, split, explode, etc. A whole bunch, 2 lowercase, 2 uppercase, right? So you've got dozens and dozens and dozens of functions here that are part of every string that you can just simply use, right? That's where the string library is in Java. It's built in. It's built into the class, I should say. Okay? So that gets us enough for next week when we'll talk more about string processing, right? Strings hold data, and you want to process that data. The most common type is going to be CSV data, comma separated value data. All right. Looks like we've got a lot of discussion on semaphores. Okay, I think this is just spam. Sorry. Somebody's asking about a bunch of crap on YouTube. I have no idea who they are. Whatever. All right, I'll see you next week.